Slide number 26. In order to be able to remove the cycle shaft, we must relieve the pressure which the cycle shaft receives from the +5 cam follower or the positive latch bail. We begin by removing the indicated +5 bail restoring spring as shown. Slide number 27. The yellow pencil indicates the lower anchor spot for the tilt and rotate bail restoring spring, or the positive latch bail restoring spring. The green pencil indicates 1 out of 5 different selector latches which are also holding the tilt and the rotate bail upwards against the +5 cams on the cycle shaft. We must remove the selector latches also if we want to be successful at lowering the cam follower. Slide number 28. We can accomplish this by simply filtering out all of the latches located under the positive latch bail. There's only one character on the keyboard which requires that combination, namely the Z. In order to be able to depress the Z, make sure that the on-off switch is in its on position, and then rotate the filter shaft top to the front by 1 revolution. Once you have depressed the Z, rotate the filter shaft again, top to the front, and watch the positive latch bail fall down under its own weight. With this done, you have cleared the way for the removal of the cycle shaft. Slide number 29. Now we have to widen the diameter of the cycle clutch spring so that it becomes possible to pull the cycle clutch spring off the driving arbor, just as we did with the shift spring. With the use of a screwdriver, yellow pencil, we hold the cycle clutch sleeve top to the rear by pressing down on one of the steps of the cycle clutch sleeve. With our left hand, we rotate the cycle shaft gear top to the front, and at the same time pull the shaft towards the left without forcing anything. Should we detect any obstruction or impediment, we immediately stop pulling and investigate the cause of it. Slide number 30. The first obstruction along the way is likely to be the -5 latch link, indicated by the red pencil, which is usually in the way of the right +5 cam. While it is possible to use a screwdriver and press down a bit on the link, it is also very possible to break the link on account of the forcing. We recommend a better way. Slide number 31. First, tilt the machine up so that it is possible to work under it. Using a spring hook, we simply unhook the -5 link from the -5 latch interposer at the point indicated by the red pencil. While you're at it, you might also remove the next link, yellow pencil. This link is the +1 latch link. The links should now fall down freely, so that it becomes very easy to remove the cycle shaft from the power frame. Slide number 32. Now we get to see the cycle clutch driving arbor. The indicated grooves in it are there for lubrication purposes. It is very important that the clutch be properly lubricated, because even when the cycle clutch spring is opened, there are points at which the inner surface of the clutch spring still rubs against the driving arbor while the machine is idling. Proper lubrication will keep the wear to a minimum. You may recall having seen the same grooves on the shift clutch arbor. It is quite frequent that one has to replace the hub pulley assembly, because of cracks in the nylon hub. To remove the pulley, it is necessary to also remove the cycle clutch latch and then the rotate bell crank. Since we have not yet shown you how to adjust the rotate mechanism, of which the rotate bell crank is a part, we will omit that job at this point. For the sake of exercise, you might now remove the motor belt and then reinstall it again. It takes doing it once in order to know that it is a very simple matter. Slide number 33. The green pencil indicates the slot on the cycle clutch sleeve which holds the right end of the cycle clutch spring, yellow pencil. Whenever we want to get at the right end of the cycle clutch spring, from now on, we can go to the cycle clutch sleeve. The outside steps on the cycle clutch sleeve offer a much greater surface for the physical contact between the right end of the cycle clutch spring and the cycle clutch latch. We will see the cycle clutch latch in the upcoming slides. The blue pencil indicates the left end of the cycle clutch spring. The left end of the cycle clutch spring is fastened to the cycle shaft by the clamp and the screw indicated by the red pencil. This cycle clutch clamp is responsible for holding 4 different adjustments of the cycle clutch in their respective positions. As a matter of fact, in a strict sense, all of the adjustments dealing directly with the cycle clutch, not the controls for the cycle clutch, are held in position by this clamp. The nylon cam directly under the red pencil, or under the cycle clutch clamp, is called cycle clutch latch restoring cam. In addition to restoring the cycle clutch latch, this cam also provides an overthrow stop for the cycle shaft. Let us quickly tell you now what the 4 adjustments of the cycle clutch are. First, the lateral position of the cycle clutch spring. Second, the angular position of the cycle clutch spring. Third, the lateral position of the cycle clutch latch restoring cam, or the nylon cam. And fourth, the angular position of the cycle clutch latch restoring cam. Slide number 34. This is the cycle clutch latch. It does exactly the same job as those parts which IBM calls clutch release arms on the other clutches. Let us see whether you can accurately describe the function of the clutch latch or the clutch release arms without any further assistance from us. Stop your tape player while you try. The clutch latch, in the case of the operational cam clutches, the shift clutch, and the cycle clutch, is that part which gets placed into the path of the rotating sleeve, ratchet, or disc. Once it is properly positioned or restored, it is able to stop the rotation of the sleeve, disc, or ratchet. The first job of the sleeve, disc, or ratchet is that of providing a means to hold one end of the clutch spring. The second job of every sleeve, disc, or ratchet is that of providing an overthrow stop for the cam or cams that are being disengaged by the action of the clutch latch. IBM uses the expression to release the clutch in order to describe the action of engaging the clutch. Be sure to become aware of the fact that these 2 expressions mean exactly the same thing. It does not matter how many times you need to review the statement just made. You must do it until you understand it. We cannot possibly overemphasize this fact. The objective of this training package is not that of renaming a bunch of parts, the names of which have originally been chosen by the manufacturer. The objective is that of making you understand and capable of repairing these clutches when they need repairs. This is only possible when you know what you're doing. Whether you call a certain part a latch at one point, a ratchet at another, a clutch disc or flange on a third place, it's in a sense immaterial. It is expected of any serious office machine repairman that he should demand of himself the ability to see right through this instructor jargon of latches, release arms, or on the other hand, discs, sleeves, and ratchets, and to recognize the true essence or functions of the part or the mechanism which he is studying or repairing. We recommend that you rewind your tape to the point at which we start to explain the function of a clutch latch or release arm, unless you can already do it. Before we change slides, let us mention that the position of the cycle clutch latch can be adjusted vertically and horizontally. Vertically, it should be adjusted so that it holds the surface of the step in the cycle clutch sleeve perfectly parallel to the bottom of the typewriter whenever the cycle clutch latch is engaged with it. This condition is easily obtained by measuring the distance from the top of the pivot pin for the latch to the top of the filter shaft. This distance should be 39.1 millimeters, or 3.9 centimeters. We will see in just a few more slides that the number 3 scribe line of the hooverometer is used to measure this distance. Slide number 35. The cycle clutch latch is held in its restored front to rear or horizontal position by the part called cycle clutch latch keeper, indicated by the red pencil. The exact position of the clutch latch in relation to the clutch sleeve can be adjusted by the front to rear positioning of the keeper. The position of the keeper is changeable by loosening the screws indicated by the blue pencil. What then is the correct horizontal position of the cycle clutch latch? Slide number 36. The horizontal position of the clutch latch should be such that it engages with the clutch sleeve by the thickness of the metal of which the clutch latch is made. This condition is indicated here by the red pencil. Since this condition is not readily visible on a machine which is fully assembled, when one uses a sharp tool such as a spring hook and slides it over the indicated junction point between the sleeve and the latch, it becomes easy to recognize whether there is a step or not between the two. If you're able to detect any step, the adjustment is not set correctly. Be sure to locate the indicated junction point in your machine, and then run a spring hook over it in order to check the adjustment. As we mentioned earlier, we will see about the vertical positioning of the cycle clutch latch during the reassembly process. Slide number 37. Here's how we release the cycle clutch, or how we engage the cycle clutch. Whenever an operator depresses a character key, the interposer, which is the part above the bail indicated by the red pencil, bears down on the indicated bail, and the bail in turn disengages the pawl which is engaged with the cycle clutch latch keeper. The part above the bail, or behind the red pencil in this picture, is the center lug of the character interposer. Every character has one of these character interposers, and they all have a different combination of lugs or lug positions. The center lug, however, is common to all of them. The center lug of the character interposer is responsible for the tapping of the positive power needed in order to drive the printing mechanism, or more specifically, to engage the cycle clutch. The other lugs on the interposers are used in order to perform the selection of the character to be printed. Slide number 38. Whenever the cycle clutch is to be engaged, the cycle clutch latch is pulled out from under the step of the cycle clutch sleeve by the action of this spring. Slide number 39. The selection of the character to be printed is accomplished through the tilting and the rotating of the type element. The characters on the element can be divided into characters belonging to the hemisphere containing the capital characters and the hemisphere containing the small characters. Notice that in this photograph, the exact center of the element, marked by a manufacturing seam line, constitutes the separation line between the two hemispheres. The mechanism which makes the selection between the two is the shift mechanism. In reality, then, the shift mechanism is only an extension of the rotate mechanism. When we are printing a character, we cannot rotate the element at the same time in an effort to select capital letters or small letters, because during the printing, the element is firmly detented or locked. Since the selection for capital or small letters is commanded by the operator, it is necessary to provide a reciprocal locking mechanism. We do not want to print the character for as long as we are rotating the element from one hemisphere to another, and we do not want to rotate the element from one hemisphere to another for as long as we are printing. You will recall that we became acquainted with the shift inhibit cam at the rightmost tip of the filter shaft when we studied all the cams which are driven by the cycle clutch. Slide number 40. The mechanism which is partially shown here is responsible for the inhibiting of the characters doing shift operations. The position of the lug indicated by the green pencil is controlled by the shift cam detent. Whenever the shift cam is rotating, this lug gets into the way of the cycle clutch latch link, indicated by the red pencil. Even when the operator goes through the motion of engaging the cycle clutch doing a shift operation, the cycle clutch cannot become engaged until the shift operation has been completed. Be sure to examine this mechanism carefully and trace the lug position to the shift cam follower or shift cam detent. It should be clear to you that the shift cam has to be in one of its detented positions in order for it to become possible to release the cycle clutch. Slide number 41. As we mentioned, this is the cycle clutch restoring cam. The engagement of the cycle clutch is accomplished by allowing the clutch latch to move out of the way of the sleeve. The disengagement of the cycle clutch is performed by first positioning or placing the latch back into the path of the rotating sleeve, and then stopping the sleeve. The pencil points at one of the two lobes responsible for the restoring of the cycle clutch latch. Notice that the cycle clutch latch restoring cam is held in place by the metal clamp. Can you remember the 4 adjustments which are controlled by this clamp? Pause the tape player and possibly write it down on a piece of paper, and then check yourself against the answer which we will provide in just a minute. The jobs of the metal clamp of the cycle clutch are: first, to hold the lateral position of the cycle clutch spring. Second, to hold the angular position of the cycle clutch spring. Third, to hold the lateral position of the cycle clutch latch restoring cam, the nylon cam. And fourth, to hold the angular position of the cycle clutch latch restoring cam. You will have to learn this one way or the other. Keep running this training program until you've got it. Slide number 42. This frame shows the cycle clutch latch restoring cam follower and the cycle clutch latch. The stud indicated by the green pencil can be adjusted up or down in order to bring it closer or further away from the cam when the cycle clutch latch is latched or in its rest position against the keeper. When the cycle clutch latch restoring stud rests on top of the indicated cam, it should hold the cycle clutch latch link towards the rear of the machine in a position which is illustrated in the next slide. Slide number 43. When the cycle clutch latch restoring cam uses the highest point of its lobes, the distance between the latch pawl and the keeper should be approximately 1/2 of 1 millimeter. Check your typewriter for this clearance. Slide number 44. Now you should simply take some time out in order to play with these parts. When the cycle shaft is assembled and out of the machine, it is much easier to examine and study its operation in detail. Thus we recommend that you do it now. Let us see whether you can answer a few questions on the cycle clutch operation. Who performs the job which in this picture is being carried out by the yellow rod? If you said that it is the job of the cycle clutch latch, very good. Can you remember and describe the adjustments for the cycle clutch latch? This is a most important question, and you should really try hard to answer it on your own. Stop your tape player while you think of the details. Well, here's the answer. 1 is the vertical position of the cycle clutch latch. It is performed with the use of the hooverometer on its number 3 scribe line. The second adjustment is the cycle clutch latch bite adjustment. You must ascertain that the clutch latch engages with the cycle clutch sleeve by the thickness of the metal which makes up the latch. The first adjustment constitutes the vertical position adjustment of the cycle clutch latch, and the second adjustment constitutes the horizontal adjustment of the cycle clutch latch. If you answered this question correctly, we extend your congratulations. Let's have one final question. Which part of the typewriter performs the job which in this picture is being carried out by the left hand? When you're ready to restart the audio tape, please continue with cassette number 2, side 1, for program number 10-1B.